In 7.1, we talked about rules of exponents and how those rules work together to take something that maybe looks complicated and simplify it. But all of the exponents that we talked about in 7.1 were integers, meaning they were whole numbers, -1, -2, 1, 2, 3, 4. But the question that arises from that is, are there exponents that aren't whole numbers or that aren't integers, and how do we deal with those? What happens if I have a fraction in an exponent? Is that a thing? What does that mean? And that's what we're going to explore in 7.2. 7.2 is about rational exponents and radicals. And remember, the word rational just means something that can be written as a fraction. So a rational exponent is just a fractional exponent. So our essential question in this section of notes, what is a rational exponent? We just sort of briefly talked about that. And how do we manipulate that? And how do we go back and forth between forms? Because we're actually going to learn that there's a relationship between a rational exponent and a radical, and those actually create two different forms. So let's dive right in. Again, a rational exponent is an exponent that is a fraction. 2/3, 1/4, 1/5, all of these are fractions. A radical, if you remember from previous years of math, a radical looks like this little check mark symbol, which we're most comfortable with as a square root sign. So for example, if I put a 4 in here and we said the square root of 4, most of you would know that that is 2. But this symbol is called a radical. What you probably are less familiar with is that sometimes we actually have radicals that have a different number on the outside, like right here. This has a 3 there, and that number is called the index of the radical. And we're going to spend a lot of times in the next two sections talking about radicals and radicals that don't have numbers in front, which is the same thing as having a little imaginary 2 in front, and radicals that do have a number in front, and that number being called the index. So what I'm going to tell you is that there's actually a relationship between rational exponents and radicals, and that relationship exists in this way. If I have an expression, for example, x to the power of 1/2, that can be rewritten using a radical. And the way that's rewritten is that the denominator of the fraction, remember denominator means the bottom, the denominator of the fraction is the index, or the number outside the radical. The numerator of the fraction, remember that means the top of the fraction, is the exponent inside the root. So x to the power of 1/2 is the same thing as the square root of x. X to the power of 1/3 is the same thing as the cube root of x. X to the power of 4/3 is the same thing as, so see this 3 goes on the outside and the 4 goes on the inside. And I once heard something that helped me remember which part of the fraction goes where, and that was someone once told me that the top dog goes in the doghouse. So the top number in my fraction, the 4, is the number that's going to go inside the doghouse, and that means that the bottom number goes on the outside. So that's just a little mnemonic, a memory tool that helps me remember which part of the fraction goes where. Top dog in the doghouse. So let's look at this top dog in the doghouse and first just really focus on how do we go back and forth between these two different notations. And when you're doing this, I want you to remember that we're talking about the same thing in different forms, just like translating in a language. We're looking at one version, the rational version, and we're looking at another version, the radical version. That's just like looking at something in English and then translating it into French, or looking at something in Spanish and translating it into German. So this relationship goes from one form to the next. So let's look at this first example. Rewrite the rational exponent as a radical. So as a radical means I'm going to have this little radical symbol that looks like a sort of check mark with a tail. Now I'm going to remind myself the big number just goes inside, 27. And then I'm going to remind myself that the top dog goes in the doghouse. So what is the top dog in this problem? The top dog is a 1. So it's going to seem kind of silly to write a 1 there, but I really want you to see where each part goes. That means that the bottom number is the base, or the index. It goes right inside this little check marky part of my radical. So 27 to the power of 1/3 in radical form is written as the cube root, or the third root of 27 to the first power. Now, the 27 to the first power is just 27, so this could be rewritten without that 1 inside as well. So that's translating from rational exponent to radical. Now let's work backwards. Let's start with the radical and let's write the rational exponent. So I know my big number is going to be x, and I know that I'm going to have a fractional exponent because I see this little index number on the outside of my root, and I see this number, this exponent, with my x on the inside of the radical. So top dog in the doghouse, the top number on my fraction is the number that is inside the doghouse, which is 3. The base, or the index of the exponent, is going to be my bottom number. So the 5th root of x to the 3rd power, and that is how you say this, the 5th root, because that's what number is in the index, of x to the 3rd power is the same thing as x to the power of 3 over 5. So let's spend a little bit more time really just focusing on those two relationships. First, let's focus on going from the rational exponent to the radical, and then let's take some time to practice working from the radical to the rational exponent. Okay, examples 1 through 3 are specifically asking us to rewrite the rational exponent as a radical. So I am going to start by writing a radical with 81 on the inside. I'm reminding myself that the top dog goes in the doghouse, or the top number goes inside, and that top number is 5. Make sure that that is written as an exponent, so it's a little number, like a superscript up above 81, not 815. Make sure I can read what your numbers are. And then the base, the bottom number, goes as the index of the radical. So this is written, and these two things are equal. 81 to the power of 5 over 4 is equal to the 4th root of 81 to the 5th power. Now, I absolutely do not want you to figure out what 81 to the 5th power is. The goal right now is just that we're rewriting between those two forms. Let's work through number 2 together. So the very first thing I'm going to do is write a radical. Now, this question is a little bit tricky because what I notice is that what is being put to the power of 2 over 5 is x, not 3. So remember in 7.1 we talked about how an exponent is only attached to the thing that it's touching. So if there are no parentheses, the 3 is not being put to a power of 2 over 5, which means the 3 is actually just 3, and it's just going to stay in front of this whole radical term. So now that we've dealt with this 3, which doesn't have any exponent, we're going to look at the x to the power of 2 over 5. So what's going to go inside the radical? That's going to be our x. Top dog in the doghouse, what's going to go inside with x? A 2. And what's going to go outside in the index? The base, the bottom, which is 5. So 3x to the 2/5 power is the same thing as saying the 5th root of x squared. I would like you to pause the video and go ahead and try and work on number 3 all by yourself. So number 3 does in fact have parentheses around 3 and x, which means 3 and x are both going to go inside the radical. And then I'm going to ask myself the same questions that I've been asking myself. What's my top dog? My top dog is 2. Goes inside the doghouse. What's my index? My base is 5. Now you could simplify this. This is a totally acceptable answer. You could also simplify this. 3x squared is 3x times 3x. We can shower the power just like we did in 7.1. That would give me 9x squared. These are both equally true, and they are both the same. They are both the radical version of 3x quantity to the power of 2/5. Now let's work the opposite direction. Let's start with the radical form and write backwards, or write in the rational exponent form. So we're going to translate in reverse. Remember that the index is the bottom of your fraction, and also remember that if there is no number written in the index, that really means that there's an invisible 2 there. So on number 4, even though it's not written there, there is an invisible 2 right here with our radical. And if you think about that, when you first started learning about what a variable was, we had things like x, but sometimes we would write a 1 in front, and we could say that 1x plus 1x is 2x. But at some point, it started being kind of silly to write the 1 in front, so we just stopped writing it. That's what's happening with radicals. It's just eventually it gets kind of silly to write a 2 there when we all know that if there's nothing written there, it stands for a 2 being there. So just remember, if there's no number, there's no index written on the radical, that means it's a square root, which means there's really an invisible 2 there. So for number 4, I'm going to have y to a fractional exponent, and the top dog that's going to go on top of my fraction is the one that's in the doghouse, which is a 3, and the index is going to be my denominator. So the square root of y to the power of 3 is equal to y to the power of 3 over 2. Let's look at number 5. Ask yourself, what is inside the radical? What is inside the radical? Well, that is 3x squared. Remember that that squared sign does not apply to the 3, but what does apply to the 3 is the index on the radical. So we are going to write this to the power of 1 over 5. You could also write this as 3 to the power of 1 over 5 and x to the power of 2 over 5 using the top dog in the doghouse rule for each individual term. I think that this is a little bit messier than writing it the way above in purple, but both are equally correct. Okay, now what I want you to do is to pause the video and try and work through number 6 on your own. Remember, that 4 in front is just being multiplied by everything that's happening to your radical. So go ahead and pause the video. All right, here we go. 4, I'm just going to rewrite, and then my base inside the radical is x. X to the power of what? My top dog is 6. My index is 3. So 6 over 3. And then this could actually be simplified because we never leave fractions unsimplified. This could actually be simplified to 4x squared because 6 divided by 3 is 2. Remember, this is still just a fraction even though it's in the exponent. So for most of this lesson, we've been talking about how do we go back and forth between the two forms. And I think that we've done a decent number of examples going back and forth from one form to the next. But one of the questions that I hope you're asking yourself is, why do I need to know how to go back and forth between the two forms? How is that going to help me? And that's what we're going to get in these last two questions. If you look at number 7, right now, you don't know how to simplify that. And actually, we are going to learn how to simplify that radical in the lesson that comes after this lesson. But as of right now, we don't know how to simplify this. So let's see if we can switch forms and then simplify as a rational exponent. So go ahead and pause the video and rewrite this using rational exponents. So I'm going to have A, top dog in the doghouse is 4, outside the doghouse is 4, B, top dog in the doghouse is 20, outside the doghouse is 4. And now that I have written it this way, I can simplify. 4 over 4 is 1, 20 over 4 is 5, and I am left with a simplified expression that I didn't know how to simplify before this lesson. And then our very last question, number 8. So let's go ahead and rewrite this radical using rational exponents. And also, don't forget that we can shower the power over here. So when I shower the power, I'm multiplying. That's going to give me x to the 6 over 2, y to the 4 over 2. And if I rewrite the square root of y squared, I'm going to get y to the 2 over 2. Don't forget, if there's no index there, that means there's a little invisible 2. And then let's go ahead and simplify this. 6 over 2 is 3, so this is x to the 3rd. Y to the 4 over 2 is going to be y squared. Y to the 2 over 2 is y to the 1st. And then lastly, we can combine those two y terms to get x to the 3rd, y to the 3rd. So recapping the most important things in this lesson, What is a rational exponent and how do we go back and forth? How do we translate between radical form and rational exponent form? So making sure that you know that the top dog goes in the doghouse and how to rewrite from one form to the next. What we just did in problems 7 and 8, we're going to build on that in the next lesson to talk about how can we simplify both in the radical form and as we just did using rational exponents. Looking forward to supporting you in class. Thanks for listening.